Alright, today, ladies and gentlemen, we have tuples. Let's take a look at it. Tuple is a collection of different data types, which is ordered and unchangeable, immutable. Tuples are written with round brackets. So this time we got round brackets, not like square-like brackets, right? Just like lists. So we have, once a tuple is created, we cannot change its values. We cannot use add, insert, remove methods in tuple because it's not modifiable, mutable. Right. And tuple has few methods related to tuples. Tuple to create an empty tuple. Yep, to count the number of specified item in a tuple. Index, define index of specified item in a tuple. An operator to join two or more tuples to create new tuple. Now creating a tuple. Empty tuple goes just like that. And so tuple with initial values item 1, 2, 3, fruits, banana, orange, mango, lemon. Right. So those are the tuples. That's how the tuple looks like. You don't have to define it as a tuple. But if you do have this circled brackets, then this is a tuple. Tuple length, so we can certainly, um, you know, um, figure out the length through the tuple. We have positive indexing similar to the list data type. We use positive or negative indexing to access tuple items. Positive indexing similar to the list data type. We use positive or negative indexing to access tuple items. Right, the same logic as for the lists, but you cannot change what's in it. We have item 1, 2, 3. First item is this, second item is this. So that's how you make it happen. We have fruits, banana, orange, mango, lemon. First fruit, this. Second fruit, this. Last index, length, fruits, -1, right? Last fruit, fruits, last index. Negative indexing means beginning from the end. -1 refers to last item, right? The same logic as for lists, right? So, yep, -4, we got item 1, 0, 1, 2, 3, so it's gonna be this one. So, second item, 0, oh sorry, -1, -2, -3, -4. So we have -3, -1, -2, -3. So we have item 3. Second item, starting from the right side, we start with -1. Fruits, banana, orange, mango, lemon. First fruit, yep, banana. Second fruit, orange, -3. And the last fruit is lemon. Slicing tuples. We can slice out subtuple by specifying range of index where to start, where to end in tuple. The return value will be new tuple with the new specified items. Range of positive indexes. Tuple item 1, 2, 3, 4, 5. 4. All items tuple 0 to 4 or 0 to infinity. Middle two items from 1 to 3. So we have 0, 1, 2, 3, 1, 2. Right, so middle two items, item 2 and 3. Fruits, banana, orange, mango, lemon. All fruits. The same logic, the same thing. Don't include item, I think. Okay. Okay. Orange to the rest. Yeah, starting from orange, right, till the rest, till the lemon. Not starting from banana. Now we have range of negative indexes. The same thing, the same logic applies. It's just a matter of experiment and it's a matter of practice. Changing tuple to lists. We can change tuples to lists and lists to tuples. So it turns out that we can change the tuple to lists. So if we have fruits of tuples, then we have lists. If we include fruits in our lists, then we will have we will have lists, right? If we print out the fruits, we have lists. So it turns out that we can change tuples into lists. Joining tuples, the same logic, the same thing as the same for the lists. The same logic applies. We can delete. It's not possible to remove a single item in a tuple, but it's possible to delete the tuple itself using del, right? So we are not using a remove function, we are using del. We're just deleting it altogether. So yeah, day 6 is over. Tuple is very something. It's something very small, yet not much complex. Have similarities to lists. So again, let's do a little bit of practice here. Let's see. Let's do a little bit of practice. Okay. So the tuple, we're not going to specify the tuple, but let's say if we have a car and it's like that, we have a car named Formula 1 as from the previous. We have car Tesla, right? So you do have those options and you choose them once. So we have Tesla, and we have what else do we have? We have a McLaren, right? We have Ferrari, right? What else do we have? We have Lamborghini. Now, all right. We have all these options, and as we have all of this, we cannot remove Tesla, nor McLaren, nor Ferrari, nor Lamborghini, right? We can't do it. So what we can do is we can literally just delete cars. That's all. And if we want to just, print the car, we won't get anything back. We literally won't. The car is not defined. Did you mean? Okay. What do you mean, GR? Cheer. What? What do you mean, cheer? What is even this? So, again, we don't have thing like a car because it's already deleted. And so if we were to remove it, it will work pretty fine. But if we were to delete the car, it's just gone. It's just literally gone. You see? Okay. What else did we have? We had also a, counting. We had counting. Right, we have a car. Can we get specific one from there? Let's say I would like to get 0 to 1, which is just Formula 1 itself, and we're going to print it. We're just going to print it. Yeah, we have just Formula 1. Good. Good. Okay. Alright. What else? What else did we miss? Let's get Lamborghini alone. We just want to get Lamborghini from there. Yep, we got the Lamborghini. Good. Good job. Yeah. Okay. Alright. Clear? Clear. Now, can we remove Formula 1, for example? Let's try it out. Remove, right? Remove. We can't do it. It's not possible. Right, so can we count? Sure, we can count. Let's call it count. And then let's count it. Let's count car. Oh, sorry. My bad. Sure we can count, man. Of course we can count. Oops. My bad again. We can just print it out. Oh, wait a second. Did I do something wrong? Did I count incorrectly? I think I'm counting something incorrectly here. Count to count number of specified item in tuple. Okay. Okay, I think I did something wrong in here. I think that's not how it's supposed to look like. I think the right way is like this, I think. No? Then what's the right way? Interesting. Okay, we have car, right? Takes exactly one argument. 0 given. Oh, we are counting the inside. Sorry, my bad. My bad. Let's make Ferraris. Let's make just 2 Ferraris there. You know what? Let's do 2 Paganis. Okay. We have 2 Paganis. Okay, good. Alright, so we're done with tuples, I believe. Can we do 1 or 2 exercises? Let's try it out. If not, then again, as I have previously mentioned, when we come to the 15th day, we will, do all of the exercises, including 1 or 2 projects as well. Okay, so create an empty tuple. Create a tuple containing names of your sisters and your brothers. Okay, join brothers and sisters tuples and assign. How many siblings do you have? Modify the siblings tuple, add name of your father and a mother, and assign it to family members. What do you mean? The last one I didn't get it. Modify the siblings tuple and add name of your father and a mother, okay, and assign it to family members. Okay. Okay, so the exercise is clear, you can do that yourself, but again, we'll come back, alright? Now, we have sets. We have sets. What are the sets? Let's take a look at it. Now we're working on sets. Now, here comes the question. So, we have lists. Whoa, what is that? Okay, we have lists, right? The lists, they used to look like what? They have this. They have these things. My bad. They have this. Now we have tuples. We have tuples. Okay, we have tuples, and they have these brackets. circled ones. Come on, what am I doing? Okay. Now, the tuples, I mean the lists, okay. Okay. Now, is it mutable? Sure it is mutable, right? It's mutable. This one, unmutable. This one is unmutable. Now, we have mutable, we have unmutable, right? And we also have sets. Now, what are the sets? What are the sets? What is a set, actually? What is a set? What is a set? So what is a set? Let's see. Let's see. Set is a collection of items. Let's make you back to your elementary or high school mathematics lesson. Mathematics definition of a set can be applied also in Python. Set is a collection of unordered and unindexed distinct elements. So we have a collection of unordered and unindexed distinct elements. In Python, set is used to store unique items, and it's possible to find union, intersection, difference, symmetric difference, subset, superset, and disjoint set among sets. Interesting. Creating a set. To create an empty set, we use set function. Empty curly brackets will create dictionary. Create an empty set. So that's how we create an empty set. Every time we gotta use this set. Okay. Creating a set with initial items. Okay. Alright. Banana. Okay. We use length method to find the length of a set. Okay. Interesting. The same thing. Fruits. Banana. Okay. Length. Okay. So this is a set. With this bracket, we call it a set. Interesting. Accessing items in a set. We use loops to access items. Okay. We will see this in a loop section. To check if item exists in a list, we use in-membership operator. To check if an item exists in a list, we use in-membership operator. Does set contain item? Okay. Alright. Yeah, to check if the okay. 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 Interesting. Now we have fruits, banana, orange, mango, lemon. Print mango in fruits. So we are basically checking the sets. We also can check lists. We also can check tuples. Adding items to a set. Once set is created, we cannot change any item, and we cannot also add additional items. Okay, so we cannot change the items, but we can add some items in it, right? So we can add with add function, not append like lists, right? But add, as simple as that. Now we have add multiple items using update, and update allows to add multiple items to a set. Update takes list argument. We have item 1, 2, 3, 4, update Add multiple items using update. Oh, so we can add multiple items using updates. Good. Interesting. Very interesting. Now we have fruits, update vegetables. Yeah. And if we print the fruits, we'll have we'll have fruits mixed with vegetables. We can remove item from set using remove method. If item is not found, remove method will raise error. So it's good to check if item exists in a given set. However, discard method doesn't raise any errors. Okay. So we have if we remove, we can if we are sure like we have this how to say item in our set, we can easily remove it by remove function. We can do that, right? So we also have pop methods remove random item from list and it returns the removed item. Okay, pop methods remove random item from a list and it returns the removed item. How? Removes random item from a set. Okay, so it just randomly removes some random item from the set if we use pop. If you're interested in removed item, fruits pop. Yeah. So we can print fruits and we can print removed item and then like, you know, check it which one is being removed or has been removed. Clearing items in a set. If we want to clear or empty the set, we use clear method. Item 1, 2, 3, 4, empty set. Okay, so we can literally like clear a set by clear function. It will not completely erase it, right? The set will still remain, but we just erased it, right? And deleting a set, if we want to delete the set itself, we use delete operator. Yeah, the same delete for for all three tuples, sets, and lists. Okay. Banana, orange, mango, lemon. Okay. Converting list to set. We can convert list to set and set to list. Okay, the same thing. We can convert to lists, just like tuples, joining sets. So how do you join them? Union, yeah, not by plus, but by union, right? You join set 1 to set 2 by union function. And so you get set 3, unification of set 1 and set 2. Example, fruits, banana, orange, mango, lemon, vegetables, tomato, potato, cabbage, onion, carrot. So we have to union it to be able to to be able to merge them. Update this method, insert a set into a given set. Right. Set 1 contents are added to. Yeah. Update this method, inserts a set into a given set. So again, union, update, the same thing, the same logic. Yeah, the same logic. Right. Same exact logic. Okay. Alright. Fruits. Right. Update. And we have the same thing. Lemon, carrot, potato, banana, mango, orange, cabbage, potato, onion. The same thing. Finding intersection items. Intersection returns set of items which are in both sets or using a symbol. See example. Set 1, item 1, 2, 3, 4. Set 2, Intersection, what does intersection do? Returns set of items which are in both sets or using symbol. So it returns a set of items which are in both the sets or using a symbol. Okay, examples. We have whole numbers and we have even numbers. The whole number intersection, even numbers. 0, 2, 4, 6, 8, 10. Returns set of items which are in both the sets or using symbol. See. So intersection is something that returns. We have, like, let's say you want to see like the same user in different, let's say, databases, and you want to see if you want to check like if the same user exists in both datasets, we can use the intersection function in order to find it out, right? Just like update and just like union. Now, checking subset and superset. A set can be subset or superset of other sets. Subset is subset. Superset is superset. String 1. Oh, okay, it's just booleans. We're just checking. Okay, checking the difference between two sets. It returns difference between two sets or using minus symbol. Difference between two sets using minus symbol. Okay, if we have set 1 and 2, the difference, the output is going to look like set 2 minus set 1. Item. Okay, let's see an example. Whole number, even number, difference. It will give us 1, 3, 5, 7, 9. Okay, the difference is 1, the difference is 3, the difference is 5, the difference is 7, difference is 9. Oh, there was a game I remember when I was a kid. I was playing this game like two characters. Like we have like original character, which you should I think it was like a factor game where like there is like a nose. They both have a nose, right? So I'll just skip it. I will not add another nose or remove the nose, right? It's just gonna, I will just remain it. But if the one have eyes and the other doesn't have eyes, so this is where the difference comes. And so that's why we use difference. Interesting. I mean, the same logic, we can apply the same logic into different programs in the future. Finding symmetric difference between two sets. Whoa, symmetric difference. There we go. 0, 6, okay, 7, okay, 8, 9, 10. What is a symmetric difference? It returns a symmetric difference between two sets. It means that it returns a set that contains all items from both sets, except items that are present in both sets. Mathematically. Okay, interesting. So it will just return sets that like doesn't exist comparing one another, right? I think it's the same as the difference, but it's the same as difference, I think. Okay. Okay, we saw the examples. Now joining sets. Is this joined? false. Oh, this is a boolean. In order to join, we use union, right? Or we use update. Okay, we're done with sets now. Very interesting, I would say, a topic in Python. We can make a lot use of it just by practice and practice and practice. Just by accepting our defeat toward not knowing the issue, right? So, right, sets. Find the length of set it companies. Okay, let's do it. You know what? Let's do it. Let's just do it. Let's do it. Okay. All right. Print length of IT companies. So we have 7. Right. Add Twitter to IT companies. Interesting. So we just use add function. Right. We just use add function. Just going to use add function. Okay. So we have add dot, I think, no. IT companies dot add Twitter. It will be added randomly in a random order. Right, here we go. Next time it will be in different order. Next time in a different order. So yeah. Oh, by the way, are the tuples ordered or unordered? Let's see. Ordered. Okay. Okay. All right. Here we go. So mutable. It's mutable and ordered. Right? Ordered. And we have unmutable. Right? And it is unordered. No, it's also ordered. And we have sets, which is unmutable. Okay. Unmutable. Unordered. Okay. Please remember this. So unmutable, tuples are unmutable, but they are ordered. Sets are unmutable and unordered. Okay. All right. Let's go to an exercise. Insert multiple IT companies at once to set IT companies. Okay. All right. All right. And by the way, I forgot to mention, this is the kind of brackets we use for sets. Same as dictionary, but not the same, right? It's not the same. Okay. All right. Okay. All right. Insert multiple IT companies at once to set IT companies. Okay. In order to, we can use, like, oh, by the way, let me do some test. Can I like add Twitter and let's say like Tinder? Can I do that? Is it possible? No. No. Takes exactly one argument. Okay. Okay. It was just an experiment, guys. chill, relax. Alright, so we have IT companies, update, right? Update, and we give it, let's not waste the time. Let's not waste the time thinking something. Right, let's just insert some virus, some unwanted virus. Yeah, there we go. There we go. Oh wait, what? What what is this? Yo, what is this? Okay. Alright, so we're not doing union. Oh, the union, okay, I'm sorry. Set union. Okay, you know what? Wait a second. Let me see something here. Let me see something here. We had update and we have union. Okay, okay, I gotcha. I gotcha. IT one comp. Okay, we got it now. We got it, chat. We got it. Okay. Remove one of the companies from set. Okay. I'm going to remove one of them. Which one is it gonna be? I don't know. I don't know, but what I know for sure is I'm going to remove one of them. I don't know which one. Right? Let's see now. Okay, we have Facebook, we have Google, we have Microsoft, right? Yep, we have Apple, we have IBM, okay, we have Oracle, we have Amazon. Do we have Amazon? We also have Amazon. Oh, wait a second. What did I do wrong? What did I possibly do wrong? Okay, you know what? I think I know the problem. Okay. We have Apple. Okay, let's see. Now we have Amazon, we have Oracle, we have Apple, right? Okay. Do we have IBM? No, we don't have IBM. Okay. I literally just removed IBM. Good. Good. Very good. Interesting. Interesting. The next task. What is the difference between remove and discard? Okay. I don't know the discard, but remove is you can like literally just remove the item that you already know existed. Right. Discard method doesn't raise any errors. So yeah, discard is it just removes. It just removes the same way. The same way. Now you see like it removes. We have Amazon, Oracle. Do we have Oracle? We have Oracle. Do we have Google? We don't have a Google, so it removed it. Now regarding the discard, it does the same thing, I think. Nah, how do you spell that? Discard. However, discard method doesn't raise any errors. Takes exactly one argument. Okay. Let's get Google. Let's get out Google from the race. Okay. How about remove? Does it do the same thing? You know what? I don't know the difference. Let it stay. Okay, we will figure out the difference. Alright. So thank you for watching. Let's see the dictionaries. I think there are a lot more in a dictionary site. Maybe I will also publish the dictionaries, but I'm not sure for now. Should we take a look at dictionaries? Alright, thank you for watching. See you in dictionaries part. Thank you.